Hello. In this video we're going to be looking some more at equations, and in particular we're going to be looking at how we solve equations which involve fractions. Okay, let's have a look then. So we're going to be using all the same techniques that we've looked at in previous weeks for solving equations. So we're going to be thinking about sort of keeping the left and right sides balanced and doing whatever we do to the left side we're going to also do to the right side. But the key thing when we're solving an equation which has a fraction in, like this one does, is let's try and get rid of the fractions first. So what I've got here is 1/3. And so what I want to do is get rid of that fraction, and the way I'm going to get rid of the fraction is by multiplying by the denominator. So in this case, that's this 3. And what happens if I multiply everything by the denominator? Times by 3, times by 3. What happens is the fractiony part will sort of disappear, and we were able to solve an equation just like we normally did in previous videos. So if I've got 1/3 and I multiply it by 3, well, I've now got 3/3. So I've got 3/3 x, and that now equals, well, 11 times 3 is 33. But wait a minute, this 3/3, that seems a bit of a clumsy way of writing 1, doesn't it? 3/3 is the same as 1, so let's just call it 1, shall we? So that's 1x equals 33. But hang on a minute, you might be saying, 1x, we don't bother writing 1x, do we? We just write x. So in fact, we're already there. We only had to do one step there. The answer is x equals 33. And that sort of makes sense from the question, because what it's actually asking us is 1/3 of x equals 11. So we're saying 1/3 of something is 11. What's that something? Well, the answer is 33, because 1/3 of 33 is 11. Okay, so that's our first one. Hopefully you agree that was not too tricky, but we're going to get more complicated as we go through. So we've got two fractions in this equation here. Conveniently, they both have the same denominator. And I'm going to do exactly the same as I did before. I'm going to multiply everything on the left-hand side and everything on the right-hand side by 9, because that is the denominator. So each term needs to get multiplied by 9. So that's this term, and this term. So let's do that. So instead of just b, I've got 9b. Instead of 1/9, I've now got 9/9. And instead of 4/9, I've now got, 4 times 9 is 36. I've got 36/9. Right, now the reason we did this multiplying by 9 was so we could get rid of these fractiony bits, and at the moment they still look like fractions, so let's think about how we can simplify this. So this 9/9, well, 9/9 is obviously just the same as 1, isn't it? How about 36/9? Well, if I've got 36/9, that's going to be enough to make 4 wholes. It's the same as 4, and I've still got this 9b out in front. Okay, so you might have spotted here that there's a bit of a shortcut we could have taken, because 1, that was just my numerator up here, wasn't it? And 4, that was just my numerator up here. Because really all we've done is we've taken this number and multiplied it by 9, and then we've divided it by 9 again. So we've got back to this numerator at the top. So you can sort of skip out this middle step if you spot that all we're doing is dividing by and multiplying by 9. We know we're going to end up with these numbers here. We're just going to need to remember that we've got 9 times this bit as well. So we've got 9b, take away 1 equals 4. We're still not finished yet, because that's not the answer. So we're going to have to get rid of this take away 1 next. What's the opposite of taking away 1? Well, it's adding 1. So I add 1 here, I'm going to add 1 over here as well, and that leaves me with 9b equals 5, and if 9b's equal 5, that must mean that b equals 5/9, and we can leave our answer like that. So our final step, sorry, I should write that in, shouldn't I, was to divide by 9. So we divided by 9 over here, and we divide by 9 over here. And 5 divided by 9 is 5/9, or just 5/9. Okay, another. Now we're getting a bit more complicated, because this time we've got two fractions, but they don't have the same denominator. So if I'm going to multiply by something to get rid of these fractions, it's going to need to be a multiple of 4, so that it gets rid of this fraction, and it's also going to need to be a multiple of 3 to get rid of this fraction. So what I could do is I could do this in 2 steps, and I could multiply the whole equation through by 4, and I could multiply the whole equation through by 3, but I reckon I've spotted that 12 will sort out both of these fractions. So if I multiply by 12 over here, and I multiply by 12 over here, what am I going to get then? Well, we're going to have 12 times s, so that's 12s. I'm going to have 12 times 1 quarter, so that's 12 quarters. 12 quarters. And I've got 12 times 2 thirds, so that's 24 thirds. 24 thirds. Good. Right, now let's think about the point of this was to get rid of our fraction bit, so let's check we've actually done that. What's 12 quarters? Well, that's going to be the same as 3, isn't it? What's 24 thirds? Well, that's the same as 8. So all I'm doing here is 12 divided by 4. That's 3, isn't it? And 24 divided by 3, that's 8. And we're still not quite finished, so we've got 12s minus 3 equals 8. Next step, we're going to have to add on 3. So I add 3 to get rid of this minus 3. I'm going to add 3 to this side as well. Okay, and now we're going to get 12s equals 8 plus 3 is 11. And final step, I don't want 12 s's, I want to have 1s, so we're going to have to divide by 12. Divide by 12, and that's going to give me that my answer is s equals 11 twelfths. There we go. Okay, we're going to keep going, and they're going to get more complicated. Okay, so this time all of my algebra is up here on the top of the fraction, but we do everything the same as before. So I've got 3x over 4. Our first step when we've got an equation with a fraction in is to get rid of the fraction, and we do that by multiplying by the denominator. So in this case, we're going to multiply by 4. Multiply by 4, and multiply by 4. So I had 3x over 4. If I multiply that by 4, I'm going to have 12x over 4. And 6 times 4 is 24. Okay, well, 12 over 4 is the same as 3, isn't it? So that must be the same as 3x is equal to 24. And if 3x is worth 24, we can just divide by 3 to work out what 1 is. Divide by 3, divide by 3. And we're going to get there that the answer is x equals 8. Okay, so I'm multiplying by 4. That gives me, where I had 3x up here, I now have 12x. It's worth pointing out at this stage that when we're multiplying a fraction like this by a whole number, the only bit that gets multiplied is the numerator part. Reason for that is, sorry, just sort of a little aside here, I'll just put in a little margin and we'll talk about why that works. If we think about what I'm doing 3x over 4 multiplied by 4, but we could, to make it a little bit clearer, we could write this 4 as a fraction, couldn't we? That 4 is the same as 4 1/8 or 4 wholes. And when we're multiplying fractions, what we do is just multiply straight across. So I do my 3x times 4, which is 12x, and I know my 4 times 1, which is just 4. So that's what we're doing here. When we multiply everything by 4, that's why the denominator bit doesn't change. It's only the numerator part that changes. Anyway, let's look at another. Okay, same kind of situation going on here. All of our algebra is at the top. We've got one denominator, and it's an 8. So we better multiply everything by 8. Times 8 times 8. And, okay, so I had a d and a negative 6 on top. I'm multiplying everything through by 8, so that means I'm going to have 8d, take away 8 6s are 48 over 8. And over on this side, 9 times 8 is 72. Okay, now let's look at this. We should be able to simplify this because we're just going to have to divide everything through by 8. So 8d divided by 8, well, that's 1d. And take away 48 over 8, well, that's just 6, and that equals 72. And again, we had that same trick happen, right, where we were multiplying by 8 and then dividing by 8. We just got back to where we started, which was d minus 6. So we've got d minus 6 equals 72. What am I going to do to solve this then? Add on the 6. If we plus the 6, we'll get rid of it from this left-hand side, and it will pop onto this right-hand side. So we're going to have just d on this side is equal to 78 on this side. D equals 78. There we go, that's my solution there. A few more examples. Okay, so this time we've got another two fractions with different denominators. So I'm going to want to multiply everything through here by something which is both a multiple of 6 and a multiple of 2. And we might be thinking 12 is a good shout, and 12 would certainly work, but I can think of a smaller number that we could multiply everything by, because 6 is both a multiple of 6 and a multiple of 2, isn't it? So if we multiply everything through by 6, we'll get to the same answer as we would if we multiplied by 12. We just won't have to deal with quite such big numbers. So let's have a look. If I multiply everything through by 6, so every single term, this one and this one and this one, gets multiplied by 6. Instead of 3 t's, I'm going to have 18 t's. Instead of 1/6, I'm going to have 6/6, which is obviously going to simplify down a wee bit later. And instead of 1/2, I'm going to have 6/2. Okay, let's tidy that up a bit. The 18t has to stay the same. 6/6 is the same as 1, and 6/2 is the same as 3. Good. So 2 more steps to solve this one then. We want to get rid of this plus 1, so we better subtract 1. And we better do the same from the other side as well. And that's going to leave me with 18t is equal to 2. And the final step then is let's get rid of this 18. So to do that, we're going to have to divide by 18. Divide by 18. And that's going to tell me that t is equal to 2/18. Now it looks to me that we could probably do a wee bit of simplifying there, because 2 and 18 are both even numbers, so we can simplify that down, because 2/18 is the same as 1/9. So that's a better way for us to leave our answer. In fact, I'm going to rewrite that over here where there's a bit more space. T equals 1/9. That's my answer there. Good. Okay, another one where we've just got one denominator and all my algebra up here on the top. And I'm going to suggest that maybe we try a bit of a shortcut, because we know what's going to happen here, right? I'm going to multiply everything up here by 5, and then when we do the simplifying, we're going to divide everything by 5. So instead, let's just go straight from, we're going to say we multiply by 5 on this side, multiply by 5 on this side, and rather than going through that whole rigmarole of times this by 5 and then divide by 5 when we do the simplifying, I'm just going to go straight to 4c minus 1 equals 35. And that's just got us to that step just a wee bit faster than we would have done otherwise. What are we doing now then? Well, we've got to get rid of this minus 1. The opposite of taking away 1 is adding 1. That looks a bit weird. Plus 1, there we go. I'm going to plus 1 to this side as well. And that's going to give me 4c equals 36. So we're almost there. Last step, we're going to have to divide by 4. Divide by 4. And that tells me that c must be equal to 36 divided by 4, which is 9. We've got 9 there. Good. 2 more that we're going to look at then. Right. Now this one looks like fun, doesn't it? Right, we've got 2 different denominators, and we've also got this big old mess over here. We've got a mixed number. So the first thing I'm going to suggest we do is let's deal with this mixed number, because mixed numbers are tricky to deal with in equations. So let's change this mixed number into an improper fraction. So first thing we're going to do is just rewrite this, but with this as an improper fraction. So everything else is going to stay the same. So I'm going to keep my 3x over 4. I'm going to keep my plus 2/3. I'm going to keep my equals. But 3 and 2/3, maybe we can draw a wee picture to think about what that looks like. 3, 1, 2, 3 and 2/3. So imagine in terms of pizzas, I've got 3 and 2/3 of a pizza. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 thirds. So equals 11 thirds. Okay, good. So my first step was to just rewrite as a mixed number. So 3 and 2/3 is the same as 11 thirds. Now we can go through our process that we've looked at before. So because we've got different denominators here, we're going to have to think carefully about what we multiply by. We could do it in 2 steps, multiply everything through by 4, multiply everything through by 3, but I reckon we can get there a wee bit faster by just multiplying everything by 12. So this term and this term and this term all need to get multiplied by 12. So that's going to give me, first of all, 36x over 4 plus 24 over 3 equals, oh, this is going to test me, 132, is that right? Yes, 132 over 3. Good. Now we can do our simplifying of those fractiony bits, because 36x over 4 is going to be the same as 9x. 24 over 3 is going to be the same as 8. And 132 over 3, perhaps this is the point where you reach for a calculator or you reach for a bus stop. It's going to be 40, is it 44? I think it's going to be 44. Maybe let's check that in a bus stop. So I'm going to write 44 and then we'll test it over here. So 132 divide it by 3. Let's see what we've got. So how many 3's go into 1? None of them, so we carry that 1 across. How many 3's go into 13? 4 of them, with a remainder 1. How many 3's go into 12? 4 of them. So yes, I was right, 44. That's good. If you need to reach for a calculator on these equations this week, that's probably fine. They get pretty tricky this week. Okay, so what's our next step then? We've got 9x plus 8 equals 44, so we want to get rid of this plus 8. So we're subtracting 8 now. Going to do the same from both sides. And that's going to give me 9x is equal to 44 take away 8 is 36. And final step then, we're going to divide everything by 9. Divide by 9. Divide 9. And that will leave me on the left-hand side, I'll just have 1x, and on the right-hand side I'll have 4. X equals 4. Good. Final example we'll look at then, I'm sure you'll be glad to hear. Right, we've got fractions and we've got brackets. Fun times. So first step I'm going to suggest is, like we did a couple of weeks ago when we looked at equations with brackets, I'm going to suggest the first thing we do is expand out that bracket. So I'm going to do 2 multiplied by this fraction and 2 multiplied by 5. And when we do that, we're going to get 6/7 is equal to, and this multiplying the fraction bit works the same as what I said before. We can think about this as 2 over 1, or 2 wholes, 2/1. So the 2 multiplies by the m, and the sort of 1 that we don't bother to write multiplies by the 3. So we get 2m over 3 minus, and 2 times 5 is 10. Okay, that's our first start. Next, we need to get rid of both of these fractions. So can we think of something which is a multiple of 7 and a multiple of 3? Well, the only thing I can think of that will do that is 21. So let's go with 21. 21. And again, this is one where we might need to be reaching for the calculator. I'm just going to tidy that up a bit. There we go. So 6/7 times 21 is going to be, oh golly, is going to be 126 over 7, isn't it? Yes. So we've got, first of all, 126 sevenths, and that's going to be equal to 42 m's over 3 minus, I can do this one, 210. Okay, let's tidy up these fraction bits, because hopefully we should find that these are now nice whole numbers. It's a difficult sentence to say. These are now nice whole numbers. So 126 divided by 7, I think should give us 18. But maybe I'll reach for the old bus stop again just to double check. So I think the answer there is 18. 42 over 3, that's going to be 14m, take away 210. Just going to double check my division over here. So we've got 126, we want to divide it by 7. So we are saying how many 7s go into 1? Well, none of them, so we carry that 1. How many 7s go into 12? 1 of them with a remainder of 5. How many 7s go into 56? 8 of them. Did I say 18? Yes, I did. I said 18. That's good. Cool, good. So we've got 18 is equal to 14m take away 210. So let's get rid of this take away 210 then. We're going to have to add on 210. And that's going to give us 228 equals 14m. I want to get just this m on its own, so we're going to have to divide by 14 in this last step. Divide by 14, divide by 14, and that means our answer is going to be 228 fourteenths is equal to m. Now there are sort of two things to fix here. One is that our m is sort of on the wrong side of the equal sign. We really want to have it looking like m equals a thing. That's a more sensible way round of writing our answer. And the other thing is, I think we've got a little bit of simplifying to do here. First of all, these are definitely both even numbers, so we could write that as 114 sevenths, and I think that's all of the simplifying we can do there. Or perhaps what we can do is change it into a mixed number. Let's do that. Let's finish off just changing that into a mixed number. So we want to think, how many 7s can we get into 114? Maybe we'll reach for the bus stop again. Let's do that. How many 7s am I going to get into 114? How many can I fit into 1? None of them, so I carry that 1 across. How many 7s can I fit into 11? 1 of them, with a 4 left over. How many 7s can I fit into 44? I reckon I can fit 6 in, and there are 2 left over. So that means that my final answer for this equation must be that m is equal to 16 with, we said, didn't we, that there was a remainder of 2 here. So it's going to be 16 with 2 sevenths left over. 16 and 2 sevenths. There we go. So either one of those would be a perfectly good answer, but it's a little bit tidier to change it back into a mixed number at the end. Whew, that last one was tough, right? Okay, excellent work. I'll see you later, guys. Bye-bye.